Hey folks, I'm Sean. I lead the Torch-MLIR project here at Google. And I mean, it's a community project, but I lead the people working on it here at Google. There's people working on it from other companies as well. This is our first community meeting, and I just wanted to, let me advance the slides. Yeah, so this is just the lightweight agenda, is just a meet and greet, like not like doesn't have to be super in depth, but just to gauge what people are interested in. Give folks an update on like what's like the code changes that are in flight right now, and then kind of the fun part where you guys get to shape the future roadmap of the project. So let me go ahead and just. Oh, yeah, and a reminder, if you're not on Discord, that's where a lot of our activity happens. And so it's useful to follow that. We also have a discourse forum. This is all in the README. And so that is not as active as the Discord channel, but you might still see some posts there. All right, so just as we can start with a quick meet and greet. And just we don't have to go down to like each individual person if there's like multiple people from the same company, but if you are an individual, feel free to introduce yourself. It's hard to kind of get like a total ordering of people on the call to like order the introductions, so I can see if you don't mind, I'm just going to call it based on the people that I know, just the people as I see them on my screen, just because then that gives us an ordering. Yeah, so I'll speak on behalf of well, I can't speak on behalf of all of Google because Google is huge, but Stella here leads a team which works on Erie, which is a inference engine and compiler, and a few adjacent projects. And so Torch-MLIR is one of those projects that kind of grew up out of Erie's, influence on, what seemed like a useful ecosystem item to have. And so I'm here kind of representing Stella's team. So Lei, Yi, and Scott are actually on that broader team. Yi and I are the ones on the Google side who are like working very directly, at the code level with Torch-MLIR. So yeah, I'll go ahead and move to the next person. Yeah, I think we can keep it maybe like pretty quick, like 30 seconds to 1 minute. And yeah, and so our interest in Torch-MLIR is basically to use as a front end for Erie and to have like a community watering hole so that all these tools can keep getting better, basically, because we're really invested in the MLIR community and ecosystem as well, not just Erie. Jeff, do you want to talk about you?
Yeah, I'm Jeff Fifield from Xilinx. Work on compilers programming tools at Xilinx, and we've been bringing up kind of an internal and flow based on MLIR. We've been using Torch-MLIR and kind of the predecessors as front ends into that flow, both for sort of training and inference offload, and as a way to kind of plug in accelerators.
Yeah, fun fact. Jeff actually was like one of the early contributors to like what became the Torch-MLIR project, and contributed a bunch of code, like the original A10 dialect, which is now the Torch dialect. So
yeah, that was kind of a hack and slash demonstrator of getting MLIR out of the Torch XLA project, basically.
Mm-hmm. Yeah, that jump started the whole thing. So next on my screen is Suraj. Actually, maybe Suraj, Eric, I don't know which one of you wants to talk about ARM, present ARM's.
Yeah, so my name is Saroj, and I work at ARM in the ML technology group together with Eric, and we have Kevin Cheng here on the call. So I was the one who jump-started the work on MLIR within our group and implemented the original Torch-MLIR dialect and the legalizations that were initially focused on the TensorFlow ecosystem, the TensorFlow and TensorFlow Lite. We have contributed the dialect to LLVM and all the legalizations to the TensorFlow repository, and it has all been quite stable. And I believe the TensorFlow Lite pieces are now being used by the URI compiler, and our interest here is in being able to have a similarly strong and stable path from Torch to Tensor, and that is our involvement here and what we're working towards building, and hopefully it'll be a really popular and useful path to many people.
Awesome. Yeah, I've seen some interest in TOSA already from other partners. So I'm really excited to see that work happening. All right, next on my screen, Anush.
Hey guys, I'm Anush, and I think we have a few of our team from Nod here. So our interest in Torch-MLIR came about from just supporting a lot of silicon vendors that have their own custom PyTorch lowerings today. Mostly, there's inference, but there's also training. And we've had various versions of our own internal hacked up flows for each customer. And Torch-MLIR kind of provided a clean way to centralize all of this and let silicon vendors focus on the back end. And so we are very involved in lowering from Torch. We with obviously Sean and Yi, our team does at some point 10 people working on just the lowerings for different ops and different models. I think our target right now is to get BERT and ResNet, and maybe even Mask RCNN, but at least BERT and ResNet all the way down for training through the Torch dialect. And so this should provide a key benchmark for being able to do the heavy lifting of is it mature enough to lower down through Torch, right? Through the Torch dialect. And so we're continuing to do that, and obviously that's one part of what we do. But as a company as a whole, we also have other layers of the stack, especially on the code gen search. Those are all things that we're working on with customers, and we also hope to have some more open source efforts on that coming up shortly. That's about Nod, and happy to answer any questions if people had anything about that.
Yeah, I really have to thank you, Anush. You Nod folks are doing, I think, actually at this point, the bulk of the ops support. So that's awesome, and I'm really grateful for that. Also, Anush played a really important role in the kind of shaping our roadmap. He Nod engaged us pretty early and has been helping with kind of some of the community outreach things and kind of interacting with PyTorch devs and kind of sowing those seeds and getting the project on everybody's radar. So thanks a lot, Anush. Yeah, so by all means, if somebody doesn't want to kind of give an intro, that's totally fine. Whatever you're comfortable with. So that was I was familiar with all those people, and so now we're into people who are entirely new to me. So Sudeep.
Sure. Hey, can you hear me?
Yep.
Yeah. Great. Yeah. So nice to meet you all. Sudeep. So I was actually previously at Toyota Research, leading the machine learning engineering team there for their self-driving car program. And so spent a lot of time on the deep learning sort of training and inference acceleration, a lot of PyTorch, and NVIDIA and TensorRT. But more recently, I've been sort of exploring just high performance inference engines on custom ASICs, hardware accelerators for more sort of the broader robotics applications. So kind of looking at Torch-MLIR as just understanding where we are in terms of ops support and just capabilities there, and seeing whether this is sort of a resource that I can use And I've been sort of, I guess, investigating things on the side as well, just more on the Torch scripting and JIT modules for custom ASICs, essentially.
Cool. Thanks. Ingo?
Yeah, hi everyone. My name is Ingo. I'm a postdoc at ETH Zurich. I'm not a compiler person. I do research on database systems, but my work has somehow led me towards compilers. And now, in particular, MLIR has caught my attention, and now I'm trying to understand what Torch-MLIR is and get inspiration from it.
Cool. Max Leventhal?
Hey, yeah, Max. I'm a random PhD student at University of Chicago, and I was completely uninterested in compilers until the beginning of the summer when I started working at PyTorch. I did an internship at PyTorch inside Facebook and kind of like dipped my toes in every end of every pool. And now I'm a compilers person for life, and MLIR seems like a good path to what I've started calling completely programmable hardware. I don't know, get back to me in about 2 years when I write my dissertation about what that means, but that's why I'm here.
Cool. All right, next up I have somebody that only shows up as a phone number to me, 1650 something 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 82. I don't know if maybe you're the only person calling in. And no.
Hi, this is Sam. I work with Jeff at Xilinx with a bit more of a focus on the back end of the compiler that we're building.
Okay, cool. Shirish?
Hi, Sean. I lead the compiler effort at a startup company called Luminous Computing. We use photonics to overcome some of the traditional bottlenecks that we face, in a highly connected, processing system. Both Laszlo and myself are represented over here. We've been looking largely at TensorFlow, but we're very interested, obviously, in this effort since we can leverage this quite significantly to streamline our pipeline in terms of the different frameworks that we can support. So that's it, and would be happy to answer any questions if people have any.
Cool, thanks. Andre?
Yeah, hi everyone. I'm a deep learning engineer, so I'm starting a new job in a company working on homomorphic encryption, and I'm starting in 2 weeks, so I won't name the company yet. We want to do AI with homomorphic encryption. So compilers, deep neural network compilers are sort of the interface to use homomorphic encryption really easily for data scientists. So I'm interested in getting to know what MLR, so Torch-MLIR is, and maybe what the differences are or similarities are to other compiler systems.
Great. Oh, I didn't know that there were so many connections with like homomorphic encryption and databases and everything for all this stuff we're doing. All right. Okay. Aaron De Batista.
Hi, yeah, I'll keep it short. I also work at ARM. I work with Suraj and Eric. I work more on the backend compilers, and I'm here just to track where this is going as a future consumer of the Torch Dialect and TOS, obviously.
Okay.
Thank you.
Bob Adolph.
Sure. Hi, I'm Bob. I spent about a decade in high-performance computing at the DoD and DOE before heading back to grad school. I did a brief stint in a startup on graph analytics. So right now I'm a researcher at Harvard. My interest is mostly in understanding sparse tensors and GNN support in MLIR. So I'd like to see how that passes through the Torch-MLIR framework, see if we can get that working.
Cool. Awesome. Yeah, there's lots of activity on sparse stuff here in MLIR. So Chuangyu Cheng.
Yeah, so I'm currently working for Imagination GPU vendor, but my work. So I'm now working on our backend compiler in the LVM part, and I'm very interested in MLIR. I think especially Erie's methodology in high performance computing and machine learning computation technology. I think last year I did some experiment on Erie GPU part, and fortunately I didn't get a support from our high level management team, so I switched team. I switched to our GPU team, and so right now in my working hour I work on LVM, and in my offline I mean off work time I'm try to be a volunteer for Erie and working on open source project. And I think because I think Erie is very makes sense to me, so I just try to keep my eye on Erie and continue working, try to understand Erie and try to understand MLIR. And I think that's why I'm here. Thank you.
Thanks. Yeah, Erie is pretty cool architecturally.
Yeah, agree.
Fei Hu.
Hello, everyone. My name is Fei Hu. I'm working at Microsoft. So my project focuses on the inference engine for the deep learning model. Most of the model are transformer-based model. And I'm kind of new to MLIR and Torch-MLIR, but I'm pretty interested in this project because I believe I can find some solution from Torch-MLIR to make our framework more flexible, powerful, and general for all our optimization. Yeah. Thank you.
Awesome. Yep. I think that the ability to make kind of more flexible general compilers is going to be one of the main advantages of MLIR. Let me see here. Laszlo.
Hi. I'm a compiler engineer at Luminous Computing. I work with Shirish, and as he said, we're considering Torch-MLIR as the way to support PyTorch as a front end for our compiler stack.
Cool. Awesome. All right, I think that's everybody. So great to meet you all. Sounds like we have a good mix of people all the way from industry to academia to students. So that seems like a kind of cool thing. I'll feel free to reach out to me privately, or I might follow up with some of you just to help understand your needs a bit more. And so we can. All right, just taking a note to myself. So we can learn how to better serve you. Anush?
Hey, yeah, just touching on that, I'd be very interested to hear from folks that are looking at Torch-MLIR. What are the models that they would like to see? Mostly because we are adding ops, and we have, if you look at the issues, we have an issue tracker for training, BERT, ResNet, and Mascar CNN, which should cover 80 ops or so, and these are all ops that I think the PyTorch devs had shown about like 350 or 70 ops that are like core ops, and so we already would be looking to validate 70-ish in the immediate future. But if there are any specific models that you're interested in, please file a tracker item, and we could prioritize it and try and make sure that they're functional. And this is just part of the community effort. We just want to know, like, for amongst us, what are the models that you care about? Like if there's a sparse model that you care about, or something else that we haven't looked at, it'll be good to bump that up so that we're not like looking at it only from our customers' viewpoint, but just as a community, we want to be able to enable researchers and new hardware and new methods to come on too. So just feel free to file a bug, and we can triage it and figure out what are the ops that are missing.
Yeah.
Some background here, history from what we did with Tensor. For the TensorFlow world, we want to figure out what legalizations to focus on at the beginning. And we had a bunch of model zone networks, something like 30 or 40 of them. And there was a script that we wrote to simply walk through each of these networks and figure out how many times each of these operators occur in every one of the networks. And then we got together a histogram of something like 70 or 80 operators that are very popular across all these networks. And we simply targeted them off. And as you add these operator legalizations, pop a whole class of networks start working. For example, conven, pooling, and maybe softmax gets to you a whole bunch of image recognition networks. And there are other categories like NLP, which have dependencies on particular operators. And if we focus on those, we can quickly get a large class of networks, models working quickly through this. So that's what we had done previously, and that would be a good approach, I think, here. If we can collect that information.
I'm creating a bug for community feedback here. So if you're feeling a little bit wary about creating a bug, so I just created a bug, and you can just leave a comment in here. Just put it in the chat. If you want to just talk about which workloads, like if you're willing or able to discuss it publicly, just throwing it in there. It's like, oh, I'm interested in graph neural networks, and here's like the library that I'm using, or here, whatever it is that you're working on. Just something that can help us to understand a little bit more. It's really beneficial if you have like an actual script we can run and get out the actual model. But even just a high level description like, oh yeah, we're interested in BERT or whatever is really, really useful as well.
Maybe even just the list of operators in the network of transparency about the model itself is the problem while in development.
Yeah. All right, so let me go on to the next slide. So just as a quick recap, so there's a longer talk where tech talk that I gave at the Mhlo Open Design Meeting, and it describes it in, Anushan and I gave, it talks in a little bit more technical detail about what's actually in the project, but as like a quick recap, we have Resonant running end to end. We have the Torch dialect, which is like scalable and kind of works, like models the Torch operators and can be easily, accommodate new operators. We have a really mature Torch script front end that, is pretty solid at importing models. An end-to-end framework, which has, at this point, like 60 like individual op correctness tests. So like if you're bringing up something on your back end, you can just, light those up one by one. If you want to support dynamic shapes, it also like natively supports dynamic shapes. So that's good. And then we are just bringing online some of the TOSA conversions. So some of those have already landed. It's really exciting. So in terms of the active work items, sorry to put people on the spot here, but I can speak to any of these just because I, have some vague knowledge of most things. But if some of these people are online, and are able to give some, like, I don't know, like 1 minute or 30-second update on where things are, that would be useful. Yi, do you want to talk about the support?
Yeah, sure. So we've been working on lowering ops for a few target models to make them, the goal is to make them be able to run end to end. So the status is for BERT inference, we added 15 new ops that's already merged, and we still have 3 ops that's under review. The expectation is that we should be able to run BERT inference end-to-end within like 2 weeks or so. And for BERT and ResNet training, we just started working on it. There are about 34 new ops, including forward and backprop ops. That's needed to implement it to bring up those 2 models. And currently, there are only 2 delivered, and 5 ops are still under review. Yeah, so there's still quite some work to get the training models running.
Awesome. Yi, do you have any like very course estimate for how long the BERT training and ResNet training ops will take to do?
We'll need to, for training model, we'll also need to add the RNG support, and with the ops, we have quite a few people actively working on it. I would say 3 months, 2 months, 2 to 3 months.
Okay, cool. Yeah, so probably sometime in Q1 that should be delivering. Suraj, do you want to talk about the status of the TOSA support and what's all the activity there?
Yes, thank you. So, as you mentioned earlier, I had put together an early set of legalizations 2 weeks ago and more last night. I'm refactoring the code a little bit, cleaning things up. We originally started out trying to make the code look like the TensorFlow legalization, but that's really the wrong way to go, and they're just using templates. So that's just the legalization part, and the idea that once we have the structure in place, we should be very quickly able to add categories of legalizations like element-wise array, binary, ternary, and then focus on pooling and conv. So the idea is to first try to saturate coverage for everything we need for floating point types to begin with. That let us quickly get networks legalized properly. And the goal for that, it will get a few dozen legalizations done in the next couple of weeks. So in parallel with that, Kevin here on the call is working on the Tensor functional regression framework. I had briefly touched upon that in Discord, but you should think about this as something like a Tensor runtime thing, not really in terms of performance, but in terms of being able to functionally validate the Tensor form of a network. So the idea is to be able to generate the Tensor form and validate bit accuracy against the original network and PyTorch running and feeding an input and generating an output to compare the 2 against each other. So that acts as a sort of fail-safe to validate that the Tensor form is the precise reconstruction of the original network. And that is fully working right now internally. We have a part that we need to open source to make it all work. And we're hoping that it can be part of the Torch CI systems so that when you do Torch legalizations, you can also validate the bit precision of the whole thing too. So we have it all working, and the goal for that is to get that thing out, at least process it as a proof of concept proposals within the next week, because it's all working now. We just need another piece out. So that's really where we are right now.
Awesome. Thanks, Suraj.
Can I ask a question, Suraj?
Sure.
So this is existing TOSA coverage. Has there been any analysis of whether the op support or the level of the op is sufficient for the workloads above? Especially as we're looking at more of the training workloads.
Yeah, that's a really good question. We would really be happy to have a list of what are the kind of model that you would like to run and legalize through TILSA. Training's kind of a little more tricky to handle, but at least for inference, we can more easily answer that question for you. But we should be able to also tackle training. There's some spectrum packed data to look at too, which we haven't really done so yet. But we would want to do so right now.
Okay, it might be good for you and Yi to connect. I mean, these are not the only models in the universe that they're working on. But, it's nice to, if we can have critical mass. And
I was thinking about that. Yeah.
Okay,
that'd be a good idea.
Awesome. Let's see. Yeah, Suraj, have you seen that bug where we have listed all the training ops for these?
No, I haven't.
Okay.
But
yeah,
it was in the chat, so I haven't really clicked on that yet.
Yeah, if you want to look at like the ops that we're implementing for the training support, it's listed here.
Okay.
So
that's a
all
great
right.
start.
Let's see. I'm not sure I saw Ramiro. Yeah, so Ramiro isn't here, so I can give this update. So Lazy Tensor is a system that's under development inside of PyTorch core, which allows tracing of backwards graphs, basically. So we've identified this as our best bet for getting backwards graphs, because TorchScript is not very good at giving backwards graphs, basically. So we were initially going to integrate this directly, but it seems that the folks working on Lazy Tensor in PyTorch core, the development is still ongoing. So we're planning to check in Q1 or late Q4 to basically do that integration once the Lazy Tensor stuff in PyTorch core is more completed. Ramiro has been actively engaging and helping make that work sort of continue. Yeah, so I'm in the process of working on some stuff for lowering shape functions and error handling, which is really important in the dynamic shape case. If you only care about static shape graphs, it's not as important. But this is something that's going to help us really scale out better the ops support and have like more uniform handling across all backends for the dynamic shape behavior. All right. So I guess Suraj gave a little bit of thoughts on what's next for the TOSA support. I just, as a quick question, are folks interested in Torch specifically, or would actually like TOSA be a good input to your system? TOSA is a little bit lower level and a bit more, smaller offset. So actually, I think for a lot of people, TOSA is probably the right path, the right input to your system. So I'm actually a little bit curious about what folks think on that aspect. And I don't know if everybody's familiar with TOSA, but we can also give it, explain what that is. But it's sort of like an op by op, kind of like a named op thing, like as a convolution op or a add op.
I mean, for us, it's more attractive than Torch Dialect, right? Just because the surface area and all that. So something at that level, whether it's TOSA or something else, TOSA seems fine.
Yeah, I got interest from another external partner for in the TOSA backend support as well. Bob?
Yeah, sorry. So strictly speaking, from a selfish point of view, TOSA has been on my radar simply because it gives real problems with sparse support and GNNs. I don't see a real path to get GNNs onto TOSA. Now, admittedly, my experience with it is very, very low. But it did concern me a little bit when there was discussion shifted towards having TOSA be the default lowering target from Torch Dialect down through MLIR, because it's going to be difficult to target. It doesn't seem like there's a way to expand the standard to handle other things that we want to do.
Well, you're here with the people who wrote the standard, so
That's
very,
right.
it can be influenced.
I was going to say, let me be clear. The standard's a fantastic thing. I applaud your work on it. I think the issue is that having the standard as an IR stuff means the path towards augmenting MLIR with other stuff that's not part of the standard puts us in a situation like, do we follow the standard? Do we follow the thing that needs more support?
Yeah. So I mean, this is where there's and I have been involved in TOSA, but I didn't write the standard. But there's TOSA the standard and the specification, or it's not a standard, it's a specification, and then there's TOSA in MLIR, and MLIR is I would say its natural state is in wanting to mix dialects at similar levels of abstraction. I think that you know, we don't want to just have a free for all there, because then that keeps everyone like that center of mass from accumulating. But you know, I'll just use an example from Erie, which we use TOSA exclusively, or like 98% exclusively for compiling TensorFlow Lite models. Is but that extra 2% is important. It's either things that aren't in the specification yet or under discussion, or that, you know, we lower to TOSA, we do an additional conversion or add more patterns and lower the other way too. And it's really kind of nice to have the backbone of math being implemented well once without everyone having to reinvent add and matmul and dot, but still have the flexibility to go wider. So I think that needs, I think there's interesting options there that kind of let us mix the specification world with the more extensible world in a way that can be pretty good, but we need to kind of find that level. Not sure if that makes sense. But.
So my perspective on this is TOSA kind of serves kind of like a waistline, or like kind of like a bottleneck. So like, you know, your backend probably doesn't care about the difference between, you know, add MM versus like an add and a matrix multiply. You know, and actually it's a decent amount of work to, you know, handle both of those. And so in TOSA, what it gives is like a kind of like a bottleneck where we'll reduce it so you only have to know how to handle like add and matrix multiply, for example. And there's actually like add BMM, and like, you know, there's like a bunch of other ones that like are all like kind of matrix multiply. And so I think from a backend, you know, like a user of Torch-MLIR as the okay, front end and backend gets a little confusing here, but if you are consuming the output of Torch-MLIR, I think what Stella's saying is basically, you know, TOSA gives us like a first order, like 5x reduction in like the number of things you need to handle, basically. So.
Also, Stella and Sean, as users, have already provided a great overview of TOSA. Thank you for speaking about that. I mean, there's nothing wrong with that. I would have to say that Stella has been contributing to the specification a little bit too. So there are channels to go through and do that, but it's not a hard and fast. It's not immutable. You would like to add to the spec, there's a process to go through that. I think it's clear on the site, and we can talk to you directly about that. But generally, the idea for TOSA is to be able to present some kind of first table. The dialect is an expression of the standard itself, and so changes start from the specification. We have a discourse page specifically to discuss potential improvements to the specification, modifications. For example, there's an upcoming change to accommodate the expression of stateful operators through those stateful tensors, so we can implement things like LSTM. That's ongoing now. I can't quite paste the link to the discourse right now, but if anybody else would like to do that, please feel free. I'll send it out later. So the idea is to be able to express something that can, in our case at least, try to target hardware design very closely, or it could be a GPU target, or something in a way that carries all of the most common case operators. It's true that some of them won't be implemented, and that it's not the goal to solve all of the problems, but try to focus on an efficient solution to the most common case problems, and that's really what TOSA tries to do.
Well, I think there's a way to an argument on, you know, what's the way to evolve it? Do you evolve it through discussion or through extension? And you know, I think that both are valid, but you know, taking some advantage of the openness of the MLIR ecosystem to, you know, allow the head to move forward a little bit, look at, discuss, congeal. You know, this is a valid way to run specification processes, and then that's one point. The other point is that I hear a lot of things in my position, and I know a lot of people have like a TOSA X dialect sitting off on the side somewhere that is like plus the extra stuff. And you know, part of what I would hope that we get to out of Torch-MLIR is flushing more of that out into the light of day. You know, like actually let's hit those edges as a community and you know, decide this should be finished. This should just go into the spec and whatnot.
Yeah, Bob. So I think it would be really useful if in that issue I linked, you could post a little bit about your use cases, or maybe even just something like, oh, this is a library that I'm using, or the ideal thing would be just like a script. It's like, here, download this script and run it, and you know, that's the model I'm interested in. So that would be really useful and actionable for us to look at.
Working on it now. I also need to reach out a little bit more to the folks at Google. It looks like Art is doing all the source Tensor stuff, and I think figuring out how these two projects meet would be interesting.
Yeah, it would be really good relatively soon if there was. I assume that there's. I don't know anything about sparse tensor support in PyTorch, but I assume that there's some tensor type that has attributes on it or something, or is it just an op-based thing? It'd be good to distill out and make sure that there's representability on what Art is doing with the sparse tensor attributes and whatnot. Because if there's not the representability for what you need, then we're kind of hopeless. And now's the time to note that.
Yeah, and there's probably a little bit of work items also in the Torch script importer, or just generally speaking, our modeling of the tensor type, if that type has to like carry extra information or something on the like front end level. But yes, also at Art's level, lower in the stack, making sure that all that kind of de-risk all that connecting.
Yeah, we're going through that process with him now on with the ERI integration. It's a multi-phase process of kind of making sure the connection works out. So
cool. Yeah, and just as a quick note, I mean, it kind of came up in the discussion, but it is like, you know, with MLIR really trivial to, you know, mix and match, you know, different backends. So if you want to use Linop with the native Linop on Tensor's backend for one op, and then the other for the other ops, that's really, really easy to set up. It's easy to mix and match. All right. Yeah, so one of the other things that's coming up next is to build out more backend extensibility. So I know some of you are, so this is backend as seen from Torch-MLIR, so kind of like somebody that sits underneath Torch-MLIR. So we're gonna work, and I'm gonna work on designing kind of like a really nicely layered ERI integration that, you know, is kind of like extensible and doesn't, you know, hard code anything. That is gonna help design that layer. But I'd like to hear from you if you want to be like a consumer of the output of Torch-MLIR, kind of what your stack looks like, and kind of what would be kind of a good input to you, or what your workflow is. I know that's kind of open-ended, but if anybody you know, has any specific sort of requirements there, I'd be happy to hear them. It doesn't have to be right now. It can be in private. Suraj?
So I just want to ask, because there's some kind of a plan to have quantized data types being supported through the input flow.
Sorry, the what? Sorry, there's construction happening near me.
Quantized data types. Quantized integers, 8-bit quantized.
Yeah.
Do we have that yet?
So the front end support for quantized. So the way PyTorch doesn't have like a really well-developed quantization story.
Yeah.
It has a quantization story, but a lot of it involves going through special ops with like special input types of like kind of packed quantized parameters.
Familiar with that.
Yeah, so we model that in the Torch script importer, and so it's not very difficult for us to like import that. But then, you know, on the back end lowering, you know, you'll probably have to take apart that like packed params thing and figure out, you know, what the heck is going on with it. But it's all just isomorphic when we import it, so it should be able to just do whatever we want. We might need to develop kind of a layer in between so that each backend doesn't need to reinvent that quantization thing. or maybe not.
Yeah.
So yeah, just
It's
waiting for
also
someone to be interested.
gap in abstraction between what's expressed by the quant apps dialect, for example, and how PyTorch does things. It's trying to figure out how to connect the two, or not at all, maybe completely independently.
Yeah, I think that there's some module level quantization parameters that get associated that you're going to need to get poked through at the edges somehow. I've looked at it enough to know that there's some work there, but I mapped so many quantization schemes in my day. I don't do that work eagerly.
So yeah, I guess the status on that is waiting for a bold volunteer to see if our toy support will actually, what's the actual work that needs to be done. All right. Yeah. So one of the other action items, like I mentioned, was this lazy tensor thing, which is being developed in PyTorch core. We're kind of in mostly wait and see state, and going to intercept that. We're able to prefetch all of the ops that are needed for the training graphs. So all that work is unblocked, but the actual integration, so you can actually run like your Python model and have it just transparently run on Torch-MLIR is that integration work is delayed by a few months. So yeah, that should be coming online sometime in Q1. All right, one of the other things I wanted to get interested in is to see if there's any community demand for the Mhlo dialect. So I think in terms of its purpose, it's very similar to TOSA. Kind of provides like a like a bottleneck layer where we can reduce all the fragmentation and variation in the torch operators. But do people already have like large existing systems that consume Mhlo? Because if not, since TOSA is upstream and it's really easy to integrate and work with, and we have here ARM is really active and doing a great job at building that community. Adding a second one, I only want to do that if there's like a really solid like community demand to build that out. So I'm just curious if anybody has like a specific requirement for Mhlo support for which like TOSA wouldn't work. All right, I'll take that as a no. So that saves us work from having to figure that whole story out, at least for the time being. All right, yeah. So I'm just now just going to open up the
real quick.
Yeah.
To anyone, I imagine a lot of people are going to be time shifted on watching this. So, for anyone, please feel free to bring these topics up on Discord or issues or discussion. These are not closed. The Torch-MLIR should be a funnel that we can get things in and out of. And if there is demand for this stuff, then and a community for it, we should do it.
Yep. Yeah, I really view Torch-MLIR like it's sort of like we skate to the puck, both on the front end and the back end. It's like what is what's the way that PyTorch wants to be integrated with? What's the way that our kind of back end customers want to integrate, and just sort of seeing how best to deliver that. And so that is obviously like a mutable function, as each person will have like a different system that they need to integrate with. So yes. Okay, so now I'm just going to open up the floor for an open discussion. We actually only have 5 minutes left. But does anybody kind of have any like kind of like a clear enough sort of picture of what they would like to see out of Torch-MLIR that they want to kind of share that and help to give us all an idea of what you want?
So do you have some high level, planning that you're doing in terms of timelines for, all the various features, or it's, kind of early to discuss that right now?
So right now our timelines have about like a 1, maybe 2 quarter visibility, just because the project is so early and the community is still building. The current like work that's, committed and staffed is basically the ops support for BERT inference, BERT training, and ResNet training, and then TOSA and the lazy tensor integration. So that basically that gives you the way to run training workloads, those workloads like directly from Python. So that's the work we currently have committed staffed as a first milestone, just to show that the project isn't a toy. And that's about a quarter, 1 to 2 quarters out, but we're still looking for feedback.
Yeah, from the Google perspective, which we're funding some of this work, is we're seeing this as a seed to plant that could take up to should start producing some results within a couple of quarters, but could take a year to really gauge some adoption. And then that's what we're ultimately looking for is this adopted and useful and enabling connectivity in the community that would otherwise not be had. And if so, then it's a thing we want to keep going with. And but that's kind of the time frame we have in mind.
Okay, from ARM's perspective, for the TOSA support part, we are trying to have enough legalizations at least to support the inference parts right now, because we do not have a very clear answer on exactly what to do with training. That's something to talk to you about. And from prior experience, we were able to bring up the TensorFlow part in about, I'd say about 2 to 3 months from start. And we're thinking something less than that, because we are aware how to get started with that. Try to opportunistically pick on legalizations that would generate the most number of interesting networks. But the question of interesting, I'm really thinking about only ourselves right now, but I'd value any interest in somebody coming and saying, hey, I'd like to run this particular network through the path, at least in the context of inference. So that input would be really, really welcome, and we can use that as input too.
Awesome. Yeah, we have 2 minutes left. So if anyone wants to sneak in anything at the last minute.
One follow-up question. So with respect to engaging with Facebook, are there any early leads or discussions with anyone at Facebook, or it's largely independent at this point?
We are working, I guess I would call it closely. I sit in on meetings with them weekly and track their development. And Ramiro, who works at Nod.ai, is actively contributing pull requests to their development. Oh yeah, Anush is the CEO of Nod, and he has all the context on that. But yeah, this is not being developed in a vacuum. We are actively collaborating and seeing how to intercept with them and what their timelines are.
Thank you.
All right. Well, thanks everybody for joining this, first Torch-MLIR Community Meeting. Next time we'll have to schedule it so it doesn't conflict with the ODM. But it's been great getting to know everybody and seeing everybody and what you're interested in. And hopefully next time there'll be even more people. Awesome. Thanks everybody for joining. I'll see you next time.
Thank you. Bye-bye.
Oh, and one last thing. Please do comment in that bug if you want to give input on your workloads. So,
what?
Oops, sorry, wrong one. This one, the 414 issue 414. If you want to give input on what models you're interested in. So, thanks everybody.
Thank you.
Thank you. Bye.
Thank
Bye.
you.